Welcome, and thank you for considering or choosing HVI for your high-voltage testing needs. This video is part of a series that covers some of the most frequently asked questions we receive here at HVI. This video covers why we don't include shielded output cables for AC or DC hipots that are over a certain voltage. Let's get started. One question we get a lot here at HVI is why we don't include a shielded output cable for some of our units. This includes AC hipots larger than 50 kV, DC hipots larger than 200 kV, and VLF units larger than 120 kV AC. The short answer is that we don't omit the cable to cut corners. We do it because, at high enough voltages, supplying one would compromise user safety and overall testing performance. All of these run contrary to HVI's design philosophy. The omission of the shielded output cable for selected units is quite intentional, engineering-driven, and in the customer's best interest. Let's dig in a bit more. For smaller units, generally up to 50 kV AC, we include a shielded output cable because it works well. The cable is lightweight, easy to transport and handle, and it doesn't significantly alter the test itself. But as the high voltage levels needed increase, if we were to supply a shielded output cable, a few different things would happen. First, for the cable to be safe, it would have to be thicker, heavier, and stiffer. This would make transporting and setting up the hypot more difficult, particularly in the real-world terrain and scenarios the equipment is regularly used for. The typical termination clamps would become too stressed and wouldn't work anymore at the size and weight needed for the cable. Secondly, the cable itself would become part of the electrical load. The capacitance of the cable increases in relation to the cable size, and it would begin to draw current levels that are significant shares of the total available output current or even beyond what the hypot was designed for. For example, at 50 kV AC, 20 milliamps of current are consumed by the cable alone. As high voltage levels increase, the needed size of a shielded output cable would reduce the usable current output or even cause the test set to trip. Both outcomes are going to greatly impact the actual test and really aren't a best practice in the field. Again, we're not cutting corners or shortchanging customers. There's very practical reasons that come down to the physics and practical realities of high-voltage testing past a certain voltage level. That's why higher voltage hypots from HVI come with output bushings, toroids, or spinning terminations. These allow the hypot users to use lightweight and application-specific connections from the hypot to the device under test. In many cases, a simple bare wire or test lead can be used, provided it's properly isolated from the ground points in order to prevent arcing. If the distance is short enough and there's a direct line between the hypot and device under test, an aluminum pipe might be used. Or another approach might be to run a wire through semi-rigid or flexible aluminum ducting, the kind you would use to vent a clothes dryer. By using output bushings, toroids, or spinning terminations, it allows hypot operators to choose and connect output leads that are lighter, more portable, and flexible, and that best meet the real-world needs and contexts of their testing scenarios. This approach gives you better device portability, more accurate test results, greater safety, and custom-tailored setups. And you're not entirely on your own. HVI is always here to help and works with customers every day to find the right configuration for your specific needs. So, to sum it all up, when there's no shielded output cable included with a higher voltage hypot, it's not an error of omission. It's solid engineering, informed by 3 generations of experience and excellence in the field of high voltage testing. Thank you again for considering or choosing HVI.